Depierre, that's me. As you can probably know by the awful accent, I'm French, so if you don't understand something, feel free to ask me to repeat. You will still not understand, but I will have tried. You can find me on Twitter. I don't do a lot of stuff there. You can find me on Facebook or anywhere. GitHub, by anonym post. Yes, there is a reason for that name. Don't ask. We all were young one day. And some are still are. Not me, but still. So as the previous title was along nostalgia and everything, this one is about, okay, it's not really nice, but it's white and black, it's normal. So why you are killing people and companies, and a possible path to a safer world to get outside of that. So I guess most of us here work in software, whatever it is, being designers or engineers or whatever. So it will be mainly about that and what happened. Before I keep going, I need to talk really quickly, because otherwise I'm going to be yelled by my boss tomorrow, about my company. So if you want to know more, you can go there. The slide will be online if you want the link. Yes, use a kitten to... so next. No. I just have to give the link and it's enough. So that's it. That's done. No, I work for Essential. If you want to know more, just come talk to me. We do cool stuff sometimes. So who here, I have questions before beginning really. Who here describes themselves as a developer? Okay. Who here describes themselves more as an ops person, or maybe someone that deal with stuff like that? No one? I'm going to be alone? Nice. Who here has ever had to set up a build system or a deployment system for this stuff? 1, 2, 3. Yeah, okay. You're the ones that are going to understand my pain. We think that the stuff you do every day in software and all is great and help people. I'm also alone. That's great. I'm going to slide on then, because it's really amazing. I'm surprised people think their stuff, what they do is bad. So let's go. Does someone knows where that slide is coming from? I stole it shamelessly. No one? Okay. This slide tries to describe approximately what we do. So there is a rainbows and unicorn realm. That's where most of you probably work. There is the scaffolding stuff. That's where also a lot of us work sometime and all. And there's the real stuff that happens that make everything work. So this is pile of tire. Who here knows what's going to happen in the next slide? Someone?
Set fire to the tires?
Yes, exactly. That's how things is. When you live in the rainbows and unicorns, everything is fine. When you live with me deep under the stuff, that's not what it is. It's awful. It's when it works. The thing is, usually when you do your stuff, you're quite happy. Things work. It's nice. When you work down there, the question is not, why did it crash? Or why is it not working as I want? Or why is it this small bug there? No, it's, how the hell is it even working? So,
it's all cached.
Oh, caching, that's a good question. That's a question that I did not ask before. Who thinks that caching is great and makes things better? Who thinks caching is great and makes things better? Okay. Who hate caching? Thanks, because it makes everything more awful. So, for those that want to know, that's the talk where it's coming from. It's from Kyle Kingsbury. That you probably, if you know a bit about it, you know more about his website, Jepson, where he tried to break distributed system and databases, and it's quite easy to break them. Spoiler alert. I advise you have a look sometimes if you want to know why everything is terrible. So how does this talk work? Really fast. There is 20 minutes for me, 10 minutes for you. That's why there is a nice chess timer here, chess clock. If someone has anything to say, you just ask me and I will switch, and you have your time to say. It can be anything. A question, you want to say something, you want to answer someone else, whatever. Do it. And really do it. I want you to participate. Of course, if you do not use your time, I will shamelessly use it. And anyone can sort of say anything. Okay, so let's try to start. I've lost a couple minutes, but it's okay. I will take that on my time because I'm really nice. Has someone read that article? It went out last week. The Coming Software Apocalypse. Nope, it's on The Atlantic, something you may find some interesting stuff sometime. And it's basically talk about how everything we do is bad. And why it's not going to work anymore. And it's sadly quite true. It's also tried to offer some solutions. Sadly, I don't agree with the solution. There's a problem. Can someone tell me how many nationwide outage incidents happened for 9/11, the 911, the US emergency number, in 4 years? Nationwide outage when no one can call 911 for more than 1 hour in 4 years. Try some number.
23.
5 is not far. 1 per year for more than 1 hour. When you can't call anything, like you have someone breaking into your house, you can't call. It's dead. No one answers the other side of the line. This happened more and more, by the way. Does someone knows what happened here? Does someone know this one? So this one is the first source of Ariane 5. So Ariane 5 was the apogee of the European space program. First time it goes out, just after Ariane 4, it's the biggest rocket at the time. Everyone, president, prime minister, everyone from Europe is there at Kourou for the first launch. Everything goes great. It's a million, not euros at that time, programs. Everything goes right, and of course, as it is a million pounds programs on everything, hundreds of millions program, everything, big piece of engineering, rocket science, everything goes right. Except, well, of course, I will not show that because I like fireworks, so that's why I'm showing it. Everything goes right? Yeah, great, we can celebrate. Everything goes right. Oh, shit.
Is that a French call?
No, it's a European one, but yeah. To be honest, what happened here, is it reused the same stuff that Ariane 4 that survived 150 launch without any problem. So it should have worked the same, right? Yeah, it should, of course.
Assume it was unmanned.
Yes, it was. Ariane 5 is unmanned. The only rocket still in activity today that can launch people is Soyuz. So where am I going with that? We build complex system. Yes, even when you do your small Hello World or your really small, simple website with Bootstrap or whatever, yes, it's complex. It's awfully complex. And that's the definition of complex system, by the way. It's system whose behavior is interestingly difficult to model due to whatever it can be. Basically, it's something that cannot fit in your head. So how many times have you played with a piece of software or something you build, and it does not work as you expect? Yeah, it's complex, right? That's the definition of complex system. It's hard, and it's a problem because we are pushing software everywhere. Like calling 911, it's software. It's a lot of different software, by the way. Just fire light, stoplight, everything, software. Your car is mainly, if you have a car, because London, is mainly a computer with wheels more than a car now. Everything, I mean, like, just the way I show, like, just this projector has probably more power inside than my washing machine or even my computer 20 years ago to just make it work in computing power. And the problem is, it's really hard to make it work well. Who here knows the IT crowd? Yeah? Are you trying turning it on and off again? Does that ring a bell? Yeah. It works, right? Have you tried turning it off and on and off again? It just works. Just works. Why do you even have to do that? Why does it always have something that goes wrong? And it's okay when it's just, you are playing Minefield or something like that and it's crash. It's okay. When you are a doctor, which is something I was talking with a physician not a long time ago, they have a small problem, is that nowadays they spend more time filling their electronic healthcare record system than time spent with a patient. Because it just never works. Like he told me quite directly that he has no trust in the fact that when he entered something, it's going to end up working at the end and be there when he needs it again back the next time. Like every time he types something, he's pretty sure that when he click save or something, it will disappear and we'll have to do it all over again. Which is an amazing UX, right? That's our healthcare system today. And that's not the only one. It's if you ask your grandmother what she thinks about using the internet, it's probably the same thing. Every time I do something, I don't know if it will work or not. It's okay, we can just press F5 and reload. Advantages, we are not the only one doing with that type of stuff. There is Crossfield knowledge. There are people doing with complex system and UN factors, and they're going to make for a long time. Especially in aviation, space, but not only, train has quite a lot also, and obviously medical field, even if that's quite new because they only accepted the fact that maybe they were also killing people in the 2000s. We still have not accepted that. I have probably killed a couple people. Maybe not people, but I've probably destroyed their life a couple of times with code I've done. Among other things, code to, no, but something really dumb, but like, you do.
This is going on YouTube, right?
Yes, I know. It's okay, it's not new. I keep saying, it's not the first time I say it. I mean, you have too, all of you have. You don't know it. But like, the time you wrote I wrote something that helped cars to know which path to use to go from A to B. Every time you go through a path that is not the good one, that sends them to, it could be like someone trying to go to an hospital when you end up in the wrong path and you never go there in time. Every time we do something like that, they believe in us, they believe in the fact that we help them getting better or doing things better. Does it really work like that? Nah, at best it kind of worked good enough for the demo. Wait, that's not true? Is that the fact that, oh yeah, we have a show and tell tonight, yeah, make it, but it's not going to work. Just hack everything into so that it works and we will do it after, yeah. No one does that? We all done that. We all did that. We all did that, right? We all did that once, yes? Oh, please. So it's not like it's a secret. We have all done that. Right? So, question for the few of you that are developers maybe. If you deploy like a big patch, a big change to your stuff, and it goes wrong, like something goes really, really wrong, what do you do?
Disaster recovery.
Roll it back.
Which you mean? Roll it back? You roll it back?
Power cycle.
That's true. That's true. That works. And if it still does not work, roll it back per cycle. So roll it back was the answer I was expecting. Just so you know, it doesn't work. Example, anything I've heard about the Nike Capital Group incident? Anyone? Yeah.
Because I've heard this before.
Yeah. Nike Capital Group, yeah. So Nike Capital Group was a pretty nice startup in high frequency trading in the New York Stock Exchange in the middle 2010, 2011, and they were quite big. Like there was a shiny new stuff. They were making tons of money. The software was really great for high frequency trading. It's important. Everything was great except that. Well, here what happened. They did a 460 million loss in 45 minutes, knowing that at the beginning of the day they only had 365 million in cash and equivalents, and went from being the largest trader in US equities to being bankrupt in 45 minutes. That's fast. What happened is they released a new patch, and for various reasons it did not work as expected. It's basically decided to trade a lot of things even if it makes no sense. And worse than that, it ended up being in a feedback loop. So it was retrading due to what it had done itself. And as nothing was making sense, we're keeping doing things that was making no sense. They rolled back the system because it was just at a big patch. So of course, that's what you do. You roll back your system. Except that what happened is that there was one server in all of them, so 8 of them, there was one server that had not got the deploy. It was still on the old code. And that was this one that was doing the bad thing. And by rolling back in the old patch, they just made it worse because it was the old code that was a problem. So rolling back doesn't work. That doesn't work. Who else here tried things like rebooting power cycling? It works most of the time, that's true, except when it's an environmental problem. It's not you. There are a lot of those stuff. They hit the kill switch after 45 minutes. To be honest, everyone on the market knew something was wrong 3 minutes after the beginning of that thing, because the market made no sense. They nearly closed the market that day. So what I mean by that is that complex systems are not only a technical thing. It's not just a bug somewhere. It's socio-technical because there are human beings in the loop, always. There's someone that is going to have to do something. And we can't go outside. There is no strong AI that's going to do the work, because if it's a strong AI, it's going to have the same problem. It's going to have a consciousness and all. So the advantage is, at worst, we are coders. We are doing this thing. The thing is, and that's the interesting thing, A complex system is socio-technical because it lives in an environment. It has users, it has operators, it has coders, it has a lot of stuff that you don't know about that are going to go there. Like who heard about the British Airways problems a few months ago? Yeah. You know that during a long time, they were thinking that basically what happened is that someone that came to clean tripped on a plug during at least 4 hours. Environment. It's not an operator, it's not anything, but that can happen. And I've seen it happen a couple of times. There is at least a couple of Microsoft services, it's known, that run from machines that live inside a conference room, and in a corner, the machine lives there. So if someone and there is a big do not unplug this one sticking in there on it, but if someone unplug it, there is something that's not going to work. Yeah.
We left a sign like that at AOL, a bunch of us. Yeah. Anyone else here want to know?
But there are, like, you can search, like Dan Liu, which now work for Microsoft, has a couple on his Twitter when he takes a picture the other day. This is a production machine, do not unplug, in the middle of a conference room. So yeah, environment. Operators, users, writers, engineers, humans are part of the system. The thing is, there's an advantage here. Human, it's what makes it work also, and we'll come back to that. Your hello world is incredibly complex too, so we talked about complex system on multiple servers and with distributed system and stuff and all. Everything is complex. Like if you have tried to do something really simple, like just do an hello world on a web browser and all, has it ever looked like what you wanted the first time? Really? No, it's never worked. Or if it works, you don't know why. Like, come to, no, it's true. Come to, one day, come to a workshop there is a couple for Elixir, for Railgirls or something like that, where we talk with complete beginners and try to look at how long it takes to take them from nothing to hello world that works. Okay?
But we know without Google.
Yeah. Most of the time, it's between 2 and 4 hours. Between a single machine and them being able to print an hello world with Ruby or something like that. And it's not even hard, it's not even complex. There are some people some computer will go fast, like 20 minutes, and some computers after 4 hours you still can't do it and you don't know why, and just say, okay, work with the one in front, in next, you are working with your neighbor now. It is more visible in distributed systems, so I know we are talking a bit about distributed system last time and all. It's more visible mainly because there are more error cases, network fallacies, if you don't know about them, go have a look. That's why caching is bad. There are more load because when you deal with a distributed system, most of the time it's because you have lots of users. And lots of users, what does it mean? It means that something that is really rare, like it's happened only 1 in a million. Yeah, well, I have 100 users by hours, so every 10 hours it happens. And if it's something really bad, it's quite bad. More impact, more stakes. Yeah, it's a distributed system. You have a ton of data, a ton of users, a ton of stuff. So if something goes wrong, it's probably going to impact more than just your grandmother and the cats. That's true. No one do a website for the grandmother in the server? That's what we all do when we are young, right? So this is a systemic problem. Everyone is concerned, and everyone, like, as a UX designer or as my designer, I work a lot with my designer closely. It does not help. Who here knows about things about Git, command line interface ergonomics? Yeah. That's great, right? A piece of ergonomics that we can learn about every day. It's amazing. Everyone loves that. Sketch is not really better for the one of you that use it. It's better, but it's not that great. And whatever you do, even a really small tool, you are concerned, it's hard. It's going to fail for some people, and you are going to end up with your issues on GitHub that say things that you don't understand, and the users that failed it probably don't understand either. Now, I'm just going to talk really fast about how we can help that, and it's going to be more interesting, I hope, for everyone. So, system thinking. Who can tell me what reliability means? Something is reliable. What does it mean?
To have the same output or same input all the time.
Yes, so for the same input you get the same output? Agree with that?
Exactly.
Agree? That's right. It's true. It's doing exactly what is specified repeatedly, so same input, same output. That's what we do generally when we do type system, test-driven development, when you use a type system, when you do a formal proof, because you are all bell and whistles. By the way, you remember Iron 5, the explosion? It was formally proof, correct. From the ground up, it's something you can do from the ground up. You know, you do your small function or your small piece of stuff, you check that it always do exactly what you want, and then you do the same thing for a thing next to it, and it works. It's nice. Yeah. Safety. Who can tell me what safety means? It's not my definition, by the way. It's one of systems thinking and human factors and ergonomics. I shamelessly steal that because I'm talking about that. Safety.
Is it the ability of the system to detect when it's not performing as expected?
No. That's interesting, but no. No, that's interesting. I'm thinking, but no. No, that's an interesting definition. I'm interested from how you go from safety to that. Honestly, I'm interested, but no.
Operates within tolerable limits.
That's close. That's more a solution to go to safety, but that's really close. Safety is quite simply avoiding loss events. Basically, you do not kill people, you do not kill your company, because when you use all your money, you love that's happened, and you don't destroy stuff. Like try to not destroy the building you are in or something like that. It's a systemic property. You can't do it from the ground up. Like you can't have the small function is safe. So if I do all my small function together, it's going to be safe. No, you have to do it from the beginning, which is why nothing is safe, because we never do it. It's hard, and it's not technical. You have to deal with humans, and that's hard. But that also means that your humans can be the way you make things safe. That's why the banking system is safe, because it's totally unreliable. You are never be sure that your money is going to go through, right? No, clearly, you do a wire transfer and all. Do you really believe it's going to work? Really? Yeah. Like, it works most of the time, but sometimes you just don't know why. You just come back and, denied. What? I have money. They have an account. Why? Or sometimes it's like, I did not pay for that. Like, it never happened to you that someone, money disappeared and you had to call your banks to get it back and all? That's something that happens, right? Strangely, we still don't lose a lot of money through that, despite the fact that it's always buggy and all. And I have worked on banking system. It's buggy. You don't want to know how it works. Honestly, it does not. So I posit, and complex systems thinking says that safety is better than reliability, because we can have the best piece of software that always do exactly what we wanted. That's great. It does exactly what the product owner asked. And all. That's great. Well, we have killed people, but that's great. We still do exactly what we want, right? It's a bit better to not exactly do what we want, but try to not kill people. Well, I'm going to go through that one, but if you're interested, go read some Nancy Leveson. Basically, she's saying that the problem does not come from code itself, but it comes from flaws in the requirement. Just, to think about it. Maybe we should push back a bit more on our requirements sometimes. So solutions, I don't have a perfect solution to offer. I'm sorry, but I can offer the same path that was used for the engineering fields, among other bridge, aviation. I don't know, but compared to 40 years ago, there is far less deaths due to plane crash. Even better than that, last November, if I remember correctly, the US major plane company celebrated 15 years since the last crash that killed someone. 15 years. We still never talk about the fact that the plane come out. We just talk about the fact of the crash. But 15 years was a major crash for an American company, major company, international company to be exact. That's not bad. That's far better than what we have for our software. If our software go up for 2 months without a bug, it's already quite celebratory. And planes are not really better than software. It's also a lot of current Boeing plane is something like 100 million lines of code, and they still do not kill people, so it's doable. So what I can offer, accept that failure will happen. You can get out without it. It will happen. There are things that are going to go wrong. It can be a small failure. It can just be because a small piece of UI move when you don't want it. It can be anything, but it's never going to do exactly what you want. Oh, I can take time with my audience because no one wanted to use it. That's great. Yeah. Software. Look, that doesn't work like I want. Bulkhead. What it means is that separate your stuff. As much as you can, try to write your stuff in ways that is not coupled, that is separated, and that if something you have to delete it or to kill it, or it dies because something goes wrong, it doesn't impact the rest. So that's easier said than done. You can't do it in nearly all languages you use, programming at least, because that's the opposite of how things are done. Like forget it, except Erlang and Elixir and all the languages Beam, it's not doable. Like JavaScript, forget it. Deal with failures at a higher level. Basically what it means that you can't save something at the level you are. You have to deal with it at a higher level. Typically, if a robot destroys a piece or something when you are working, you can't deal with it inside the robot. Because if the robot did these errors, it's because it was believing that what it was doing was great. So you have to deal it, you have to come with someone to repair it. Same thing. You always have to have something else that check on it and deal with it. You can't deal with it on the same place. Because if you deal with it exactly in the place where the problem happens, why the problem did happen at the first time? You should know how to handle it. Please stop doing that. Anyone here has done any root cause analysis any time? No? Yes? Yeah. Don't do that, please. That doesn't work. It's even worse. It makes things worse. Blameless postmortem, when something, if something goes wrong, and it's not only for the people working on developing things and all, if something goes wrong, please take the time to look at why. Yes.
Why does root cause
Because there is no root cause. That doesn't exist. This ID is wrong. There is no root cause. The ID
How do you do a blameless
postmortem, yes.
So how do you do a postmortem?
Okay.
You're not looking at what the root cause was.
Because you look at the causes.
Okay.
There is a really difference here.
Plural. Would that
Well, possibly yes. Basically, that means that there is one thing that created the whole problem. Because there is a root cause, right? There is a root. The thing is, and there is another assumption here. The other assumption here is that there is a link between the cause, there is a logical link, a causality between the cause and what happened.
That's why it's cause, you know?
Okay, but
Yes.
the operative term in there is not root cause. The operative term in there is analysis. And I'm being unbelievably pedantic with you because I'm unbelievably pedantic.
So that works for me. Do analysis. I'm okay with that. But there is a reason that in the whole industry it's called RCA and not A. Root cause analysis, not analysis. Yes.
Your point there, it has to be some level of causality. It can't be
So,
stochastic.
nope. No causality doesn't mean it's not stochastic. So, no causality does not mean it's not stochastic. So what happened most of the time, and we can talk about that later more if you want, but what happened most of the time is that it could have been a lot of other things that goes wrong.
Sure, but that just means that
Let me-
open context.
Yes, let me finish, please. What can happen is that a lot of things could have gone wrong. What happened most of the time is that it's rarely a single thing. What happened most of the time is there is a lot of small things that push your system outside of its safety boundary for any reason. And what happened is that when you are outside of the safety boundaries, whatever happened, because failures always happen, whatever happened end up escalating into a full incident. But that does not mean that then saving that thing will help at all. Because most of the time, if you are still under your safety boundaries, these failures will probably never escalate in a full incident. Does that help? Yeah.
The cause may not be singular and it might not be linear,
So,
but it's certainly not stochastic.
no, it's not stochastic. But the problem is not even that it's singular, it's that it's a root. It's really rare that it's a root, but yes. So blameless, yes.
So we've got a couple of minutes left.
Yeah.
So let's
I'm nearly to the end anyway.
on the
So
beers.
yeah, I'm nearly in the end anyway. I don't drink alcohol, so I'm okay with staying longer. So blameless postmortem, please, even if it's not a big thing at all, just look at what happened and why, and write it somewhere where people can find it. That would be easier than going on the internet next time something like that happened for someone and asking on Stack Overflow. Okay, just write what happened, why it happened, what is the whole context that make it happen, because most of the time it's really just a small thing. And if possible, explain also how you are thinking about solving that, because that will help everyone and it will help yourself. It may seem like something you're like, yeah, but not for every small piece of stuff. Maybe do not write it, but make it something that is shared knowledge among your team and among the people that you work with, because that will help them too. There's a lot of stuff that we just all do all the time in terms of small mistake. Like, I don't know, probably know more than me, stuff that everyone makes that mistake, right? Then solve the problem at the root. So, not even as a root. Solve the problem itself. Create an environment. I'm going back to that. Create an environment inside this mistake cannot happen anymore. A good example for programming stuff would be Rust versus C right now. Debugging at first class makes it easy to understand what happens, which is honestly not how most of us do stuff. We just do stuff. Visibility, stop lying to ourselves about thinking things like, it ran on my machine, or that's not my problem, that's an ops problem, that's a designer problem. No. It's all part of our stuff. Economics, please do stuff that are easy to use. And by easy, I do not mean with training wheels. I mean that the default or the thing you do without thinking are the things that work. Okay? Not Git. Please don't do Git. Distributed system try to deal with that. Most problem happens with the interfaces, which ergonomics go back to because it's an interfaces between two systems, the humans that use it on your piece of stuff, sometimes. In general, no one handle it. In general, we just let things go wrong, and someone is going to, and if we are lucky, someone is going to come in and solve it. This someone can be the grandmother just pressing reload on your web page when something goes wrong. That's usually how we handle it in a web page. Like, oh, it has crashed, it does some bad thing. It's okay, they can just reload. Security. If there are some people here interested in security stuff, like it's quite close to safety, the same type of principle, work quite well. That may be a way you introduce it, but ergonomics may be a way too in your team. And if you want to know more, there are a lot of interesting things here. If you are more on a designer side and front-end side, you may want the Field Guide to Understanding Human Error by Sidney Dekker. Sidney used to be a physician. Now he's worked full-time on human factors and ergonomics. How Complex Systems Fail by Richard Cook is really great. It's a free paper online. It's a 5-page PDF that is really easy to read. Richard is used also to be a physician. It's really easy to read. Please read it. Please. It's mostly about, it works mostly for medical stuff, but it applies as well for us. John Anspo used to be the CTO of Etsy, not anymore because Etsy. He has a really good blog post that will explain far better than me why root cause analysis is a bad idea and the danger of the five whys. If you use the 5 whys, please stop. Engineering a Safer World by Nancy Leveson. You can find it free online on MIT Press. It's more for engineering stuff, but it does work for a lot of stuff. Most of our case study are from chemical industry or the army, because the army does postmortems that we can see, which is something we don't do. And read postmortems, it's really hard to find them for our own stuff. And that's all I have, so thank you very much. Yes. Yeah. Yes.
If you just quoted an example of best practice from a group of people who kill people.
Yes, about how to not kill their own.
Okay.
In that case, it's how they it's a friendly fire from F-15 to helicopters that kill something like 15 people.
Probably the requirement.
In a way, yes. Interestingly, yes.
Awesome.
All right.
Yeah.
Thank you very much, Thomas.